Question number 35. The above image shows a corrective measure for a particular defect of vision. First, identify the defect of the vision and state what kind of lens is used to correct this deficiency. Second part, draw and label a ray diagram that shows the defect of vision in the above case before correction. So here we have 2 points. Initially they are shown by the dotted rays, and finally the point second where from the rays are actually originating, and after reflection through a lens, convex lens, and then eye lens, it is converged at the retina. Question number 35 में the question is कि there is a diagram given here which is the correction in some eye defect. So what the diagram is showing is that some sort of eye defect is there which has been corrected through convex lens. So the question is, you have to identify the defect and by which lens it has been corrected. And the second part, you have to show the defect with the help of ray diagram. That means you have to redraw the ray diagram showing the what exactly the defect is. So here, the first part, as far as we see, this is the object and the rays are coming from here. If this lens is not used, then what will happen? The rays will not be able to meet at the retina. That means the person having this defect will not be able to see this object. So this object is placed near the eye. That means near. So this person is not able to see the nearby objects, but is able to see far away objects. So the defect is hypermetropia. Hypermetropia. That means dur drishti dosh, that is hypermetropia, and this lens is convex lens, so it is corrected by convex lens. And the second part, we have to show the defect. So in this case, if the object is kept far away, that means at infinity, then this person is able to see, that means the image is formed at the retina. But when the object is placed near the person, that means near the eye, then the rays are not able to meet at the retina, but they are focused away from the retina. So that is the schematic or Venn diagram showing the defects of that is hypermetro defect or the defect of that person which is given in the question. So here we need to converge these rays so that they will meet earlier. And the reason for this defect are, first reason is the focal length of eye lens is increased. Although this you are not supposed to write, but for your understanding, I am just telling you, you have to draw only this diagram which is showing the defect of the vision, that kind of vision. So you have to draw only this. Even you need not to draw this, but समझाने के लिए मैं आपको पूरा समझा रहा हूँ कि this happens, this kind of defect is due to the first one reason is the focal length of eye lens is increased, or the second is the eyeball shrinks. Eyeball shrinks. यानी eyeball अगर यहाँ होती तो क्या हो जाता, बन जाता, लेकिन वो shrink कर गई, तो इसलिए क्या हुआ, the image is not formed at the retina. So the two regions are there and the diagram will be shown like that. Here the person is able to see the distant objects and this person is not able to see the nearby objects. So this kind of defect is known as hypermetropia, and this is being corrected by convex lens. Because if you put a convex lens over here, so these rays will be get converged over here, and then further they can be converged with the eye lens, and easily it will be obtained on the retina. So this is how the defect is identified. The defect is hypermetropia. That means the person is not able to see with the help of, without the help of this lens, this person will not be able to see that means the image will not be able to form at the retina. So will not be able to see as in this case. But when you place in between the object and the eye a lens, that is the convex lens, then first this convex lens converges these rays. These rays are moving like this. So it is being converged by this lens. So further this is converged with the lens and able to focus it at the retina. That's why it has been corrected. Question number 36. A student needs to make a 0.12 ohm resistor. She has some copper wire of 0.80 mm diameter. Resistivity of the copper is 1.8 into 10⁻⁻8 ohm meter. First, determine the cross-sectional area of the wire. Second, calculate the length of wire required for the 0.12 ohm resistor. Number 36. In this question, a student needs to make a 0.12 ohm resistance with the help of a wire, and the wire is of copper wire of diameter 0.80 mm, and the resistivity of the copper is given to you 1.8 into 10⁻⁸ ohm meter. Means what is there? The student wishes to make a resistance or a resistor of 0.12 ohm resistance having a wire of diameter 0.80 millimeter, and the resistivity of the copper, because the wire is of the copper, so it is 1.8 into 10⁻⁸ ohm meter. It is given in the question. And the first part is asked that determine the cross-sectional area of the wire. So you have to find the A, and the second part, calculate the length of the wire required for this resistance. That means you have to find length also in the second part. So the first part, so D equals to 0.80 mm, that is 0.8 into 10⁻⁻3 meter. So the radius will become 0.4 into 10⁻⁻3 meter. And the cross-sectional area is always equal to what? No, not 2 pi r. It is pi r square. So this is pi r square. Because this is the cylinder having cross-sectional area in the form of the circle. So wire is always having circular cross-sectional area, and the area of the circle is pi r square. 2 pi r is the circumference. So here pi is 22/7 into r is 0.4 into 10⁻⁻3 square. So this will be equals to 22 by 7 into 16 into 10 to the power, this is 0.3, so 4, so 4 to the 8, so 10 to the power minus 8, that will be meter square. So thus you can just have it 16 to the 32 and 62 to the 32, 35 divided by 7 into 10 to the power minus 8, so that will be equal to 7 5s are 35 and point or almost 0 and 3 into 10 to the power minus 7 meter square will be the cross sectional area. Now the second part is the length. Calculate the length which is required to make the resistance equal to 0.12. We know the resistance is equal to rho L by A. So that 35.2 by 7 into 10 to the power minus 7 into area. Area is this into resistance was 0.12 and divided by rho, and rho is 1.8 into 10 to the power minus 8. एक बार देखिए R A upon rho. So A is 35 is just calculated. We'll use this one. So 35.2 divided by 7 into 10 to the power 1 decimal here, so will be minus 7, and the resistance is 0.12. We have already given, and the specific resistance, resistivity 1.8 into 10 to the power minus 8. So here we'll get 35.2 upon 7 into 12 into 10 to the power minus 9, 2 here 9, and divided by 1, or you can say 18 into 10 to the power minus 9. So this will get cancelled. Now here 6 2 are 12 and 6 3 are 18. So this multiplied by this, you will get 70.4 divided by 7 into 3. So here 70.4 divided by 21, and that is equals to 3.63, then 74 again, and then again decimal 3. So 63 and 7 and 11, and that nearly almost 5. 5 1 5, 5 2 10, so 115. So nearby this much is the length. So the length of the wire will be 3.35 meter. Let us see once again. एक बार थोड़ा दोबारा देख लेते हैं. The child or the student has to make a resistor of resistance 0.12 ohm from a copper wire of diameter 0.80 mm and having resistivity of the copper 1.8 into 10 to the minus 8 ohm meter. So here first part was find the cross sectional area of the wire. Since the wire is always having a circular or cross sectional area or cross section as a circular form, so this area we have to calculate, and the area of the circle is always pi r square. So it is given d equals to 0.80 mm. That means 0.8 into 10 to the power minus 3 meter. So here radius will be equal to 0.4. Half of this 0.4 into 10 to the power minus 3 meter. So here area is pi r square. Pi is 22 by 7 into 0.4 into 10 to the power minus 3, and this whole square is 1 decimal is here and 3 are minus here, so it will become minus 4. So squaring it becomes minus 8, and 4 square is 16, and 22 by 7 as it is. 16 to the 32 and 16 to the 32, 35 remainder, divided by 7 into 10 to the power minus 8, and after dividing this by 7 we get 5.03 and one decimal here, so it will power minus 7, so 10 to the power minus 7 meter square. So this is the cross sectional area we have calculated. Now the second part is we have to calculate, the child or the student has to calculate the length required. So the length required will be, as we know, this R is given by rho L by A. That implies this L will become R into A upon rho. So the value of the R is given 0.12 ohm, and the area we have already calculated. So I am not taking this because it is approximation. So we will take it. So this is 35.2 divided by 7 into 10 to the power minus 7 and divided by the rho, that is 1.8 into 10 to the power minus 8. Now just multiply it, just taking the decimal from these two decimal here and 7 here, then we will get minus 9, and this decimal also take here, then it will 10 to the power minus 9. So they will cancel out. Shortcut करिए, तो 6 2 is 12 and 6 3 is 18. So multiplied by 2 you will get 70.4 and divided by 7 into 3, 21. So 70.4 divided by 21, 21 3 is 63, remainder 7, it becomes 74, then 21 3 is 63 again, then it becomes 11, then 0, 110, and if it is 3 times, 5 times, so 5 1 is 5 and 5 2 is 10. So it is 105. So it is 3.35 meter. So this way the child needs a wire of 3.35 meter to develop a resistor of resistance 0.12 ohm from a copper wire of diameter 0.8 mm and resistivity 1.8 into 10 to the power minus 8 ohm meter. So